So let's get Pyohio started here with demystifying AI agents with Python code. William Horton is going to be speaking to us. So thank you. Take it away, William.
Thank you. Yeah, welcome everybody. This is Demystifying AI Agents with Python code. There were some shifts in the schedule, so just to make sure that this is the presentation that you're going to see here right now. Okay, so everyone's talking about AI agents. These are headlines literally just I compiled from the last week, all about AI agents. Companies that are older, like Walmart, are using them. There's new companies raising money. You've probably heard something about AI agents. That's probably why you're here. What are AI agents? You know, I think that my best answer is from Blades of Glory. Nobody really knows what it means. And it definitely gets the people going when you talk about it. But more seriously, people have been trying to figure out what exactly a good definition for AI agents is. This is from Simon Wilson, who people in the Python community might know as the co-creator of Django. He's now also, in my opinion, one of the best writers about applying LLMs in software. And so he made a tweet last year to try to crowdsource definition. And I think my favorite reply was probably this one from Princess Bride. But, you know, people started to coalesce around answers that kind of got to the point of like, okay, an agentic application, the LLM decides control flow. That's from the creator of LangChain. The other one's from the creator of CrewAI, which I'll show in my demo. And it's like kind of using LLM reasoning. So these are getting toward a consensus on what agents are. But this is my favorite one. This is from Swix, who founded AI.engineer. They run some very good conferences. And this breaks it down as an agent is an LLM plus memory plus planning plus tools plus while loop. And this tweet is actually what inspired me to give this talk, because I saw while loop and I was like, oh, a while loop, that's something that essentially all Python programmers know how to write. And so what if we could break this all down into concrete Python to explain to people how exactly to implement an AI agent according to this definition? And you know, you might have the question, is it all just marketing hype? My answer is kind of yes and no. Some people are just using it to sell stuff. Like, that's just the truth. But I do think there's a real like kernel of useful technology, and I hope that's why everyone is here, because I think at the bottom of it, this is something that's going to be around for a while and something that is going to become increasingly useful, even if right now, there's a gap between how like marketing people use it and how we use it like here among software developers. So that is the purpose of this talk. You might be wondering, who am I? Why do I care about AI agents? I work as a machine learning engineer. I've been working in healthcare the last 5 years. I worked for a company called Included Health, where I built out our GenAI platform. As of a couple months ago, I've started working at a company called Maven, where we're also building out an AI platform. This is my social media. Horton here's a foo on Twitter. Horton.here's a .foo on Blue Sky, because I got creative with the custom domains. And just to tell you a little bit about Maven, we're a virtual clinic supporting women and family health, so everything from fertility, pregnancy, postpartum, menopause. We use a lot of Python. All our services are Python. We are hiring remotely, so if you're interested, get in touch with me. And not just if you're interested in AI and ML, we have roles in back-end data, infra, and analytics. And for the last bit of the intro, I just want to say thank you to Pyohio. Way back in 2018, Pyohio was the first conference talk that I ever gave, so I wanted to give a shout out to the conference for giving me a chance back then. My talk was called "You Can Do Deep Learning," and back then it was all about image recognition, because that was the big ML AI topic, and it was kind of how to build your first convolutional neural network. So again, thank you to Pyohio. I went in 2018, 2019. I went to the virtual one in 2020, and this is my first time back. I'm really glad that we can all be gathered here together, because I think it really is an amazing conference, like one of my favorites for sure. So thank you to the organizers. Like was said in the keynote, it takes a lot of work to do this, and I'm really appreciative of the opportunity. So yeah, diving into this, essentially what I hope to show you is how to translate the concept of AI agent and these parts that I mentioned, like tools and memory, from these terms into concrete Python code, so that you can understand behind the scenes what's going on. And so I have a link to the code here, because I know sometimes it can be hard to see code on the screen. I'm going to be going through a notebook, but if you want to follow along with by yourself, this links to the GitHub repo. There's also a bit.ly link there as well. It's just agents-Pyohio on bit.ly. So give people a little bit of time to grab the link, and then we can get into the code. Yeah, I'm going to show it. I'm going to show it up here. This is just because I know sometimes it's hard to see on the screen. Okay, so I have a notebook. This is what we're going to be walking through in terms of the implementation. People can read this like, okay, I could probably bump up one zoom level if needed, but just let me know. So I kind of laid out our basic definition. It's an LLM plus memory, plus planning, plus tools, plus a while loop. So the first piece is an LLM, and how many people in here have used an LLM in some way? Yeah, so this first part is the part you're most familiar with. If you're using it as an application, a lot of people have interacted with an interface like this in ChatGPT. And so the first thing we want to figure out is, when I'm writing Python, how do I replicate this experience of being able to type into ChatGPT and get an answer back? And so I'm going to show you the OpenAI Python SDK. But I do have a note in here. If you want to look later and you want to use a different provider, whether you use Gemini, Anthropic, or even Ollama for local, I have code in here to be able to connect to those, and it'll work for you as well. So this is kind of our starting point, is an LLM call where we give a text input and we say, tell me about Python programming in a few sentences. And we can see that the OpenAI SDK gives us back this kind of complex JSON response, but really what we care about is the actual text. So we can print this out, and it's a decent summary of Python in a couple sentences. So this is the LLM part of an agent, the part that you're probably most familiar with, and something that you can tweak in ChatGPT's UI, but you might not be as familiar with, is you can also give the model instructions. So this is called a system prompt, or OpenAI has started using developer prompt as a term. So I can say, talk like a pirate as my system prompt and send the same question. And we see that it gives the same answer, but now it's in pirate language. So that can be kind of fun. Sorry, I meant to clear my cells. So that's the LLM part. The second part is memory. And this is important because the API I just showed you through the SDK, it doesn't actually retain the history of the messages. So we need to add another component to get toward an agent by tracking what we've said. And this is a demonstration of what I mean. If I just have a function for calling the LLM, I can say my name is William, and then I say, what is my name? It has no idea. So this is the problem we're faced with moving from LLM to agent, is to say, how does it remember what I've said to it? And the way to do this with this API is you basically keep putting messages into this list that you're sending. So I can say, okay, the first message in the list was my message, and then the agent said something back to me. So in this case, it said, hi, William, how can I assist you? And then I said back, what is my name? So I have these messages in order in this list, and this is how I represent to the chat completions API we're using, that this is like a conversation that has happened, and I want you to give me now the next message. So now it can actually tell me my name is William. that's great. And if we wanted to take that and kind of encapsulate it in a class, we could have the class keep track of this messages list, and we could continually append to it. And so we could have this nice abstraction where we say, I have a bot, it's tracking the messages, and we can see inside of like the bot's state that it has this list of messages. It has what I sent, it has what it was replied to, and so now when I say bot.chat, I get the same result as when I did it kind of manually above, just like putting the messages in. So that's our second component, and we see that the bot has kept track of all of these messages in its memory. So that's the second component. We have an LLM. It wasn't able to remember anything. Now we've added in memory, so now it can tell what I'm saying to it and reference things that I said in the past. So the next part is planning and tools. This is the most complex part, and I think this is the part I'll probably spend the most time on. So let's say you wanted your LLM now to call a Python function. Why would you want to do that? Without the tools, the LLM, one, can't access information beyond what it was trained on. So a lot of these models were trained up till 2023 or 2024 now, maybe into the beginning of this year, but it doesn't know anything beyond that. It couldn't tell you, like, what is today's date? What is the weather? You also might want the LLM to start interacting with the external environment. Maybe you have an API you want to call to update something. So this is why we incorporate tools with an agent. It makes them more useful, more up to date. Just one quick note on like tool versus function. Early on, people called them functions. Then now people are shifting to tool. People kind of use them interchangeably. Technically, in OpenAI's definition, like a function is a kind of a tool. So functions are like one tool you can give to your agent, and there's other tools, but I might probably use them interchangeably. I don't think people have a strict definition. So just to demonstrate kind of the failure mode, if I say, where is Pyohio this year? And I ask just the LLM part, it's going to tell me, okay, so two things went wrong. It thinks it's 2024, and it also apparently hallucinated where Pyohio 2024 was, because it was not at Ohio State. So this is demonstrating the problem of an LLM for questions like this, and the reason why we need tools. I want to get up-to-date information to avoid hallucination. So we also know, like as Python developers, I could write a function that helps me answer this question. So this is using the Serper API, which is an API for searching the web. And using requests, I could write this function and say, okay, get me some information about Pyohio. And right here, actually, in the first result, there's the answer. It's at the Cleveland State University Student Center, where we all are. So the challenge becomes, how do I get the LLM to use this function? It's combining the strengths of deterministic code with the strengths of an LLM. So the LLM can understand the query well, and it can then generate an answer in natural language. But the search is up to date, and it has accurate information. And so the power of an agent comes in combining these two things and using both LLMs and deterministic code together to get the right result. So basically, off the top of your head, if you were starting to figure out how do I get the LLM to call this function, well, we have an LLM, we can give it instructions, and it returns text. We have a function we want to call. So the first place to start is to just tell it, okay, you have a function, you should call it. So I can give it this instruction in the system prompt to say, you have a function, if you want to use it, use this syntax, just say search web and put the query in it, right? And so I can use this same completions API we've been using, and oh, here's another problem. Again, it doesn't know the current date. We've gotten it to now tell me use the web function, but it wants to search in 2024. So we're just going to fix that by also putting the date into the instructions. So we're saying, okay, you now know the current date, and let's see if it now makes the right search, right? So now it's able to tell us, I want to search the web to find this information because we've given it these instructions. And we can use a regular expression to then extract this parameter, So we can get this, and then we can pass it to the search function that I've written, and we get these results. So that's the kind of starting point toward how you would actually get the LM to use these external functions that you've written. So here's kind of the whole flow, is I would give it the instructions, and then the user is going to ask the question. Then we see that it returns this result of searching the web, and then basically I give it the results back. I say, you asked to call this function. I called the function in my code, and now I'm giving you back the information so that this overall like agent system can complete an answer. So this should work. Yeah, so we've gotten a right answer. By incorporating an LLM in a search tool, instead of telling us it's 2024 and to go to Columbus, it's 2025 and it's going to send us to the right place. So just to kind of recap that section, because I think tool use is probably the most important, but also going to be the most complex. Overall, to get an LM to use your functions as tools, you want to tell it the functions it has and the parameters to use. So this was a search function, and you need to pass in one parameter that's a query. You need to then extract the function call and the parameters it used. Then in your code, you run the function, you give the information back to the LLM, and then we get this final text response. And that's how the interaction between LLMs and functions or tools in like an agent system works. Luckily, you don't have to actually do all that yourself. The providers have realized that like doing like this is error prone. Like what if everybody had to come up with their own syntax for describing their functions and their parameters? That would be really annoying. And so the providers have actually trained the LLMs to recognize certain ways of describing functions. This is how I would describe the search function. It's using an OpenAI spec, so that's something you might already be familiar if you've used like web servers, because they also describe their endpoints using OpenAPI. So this is a standard spec for a function that I can now pass to an LLM, and I pass it in this field called tools now. So I've defined this according to the way that it's tricky, OpenAI and OpenAPI really trips me up, but I've created an OpenAPI spec for my function, and that's how OpenAI expects me to pass it to them. So now we can see I get back this JSON response, and inside, this is the part I care about, is in the response it's telling me, call your function that you're named search the web with these arguments. So it's given me a query and a function similar to how I did it above, but it's much easier to extract now, because all I have to do is load this JSON to get the parameters. I don't have to use regular expressions or something like that, because it's now given me in a structured API. So I can get that the query should be this. And much as I did above, I can pass that to my search function, and I get results. And so this is showing the same thing I showed above, but now we're using the built-in providers APIs. We say, we give it instructions, we give it a question, it gives us back a response that includes a function call, and then there's a special role that's used, which is called tool, and this is what I use to represent the results of calling this tool. And so you can see I just dumped the search results into this message, and this is now the full conversation we've had. I said, I gave it instructions, I asked a question, it gave me a response back saying call this tool, and then I called it. And I give it the results, and we get back the same answer as before, but now we're actually making use of this structured tools field, which makes a lot of the rest of the code much simpler for us, which is great. The other important thing to know is like, this is a very simple form of this planning concept in agents, but it doesn't have to use the tools if they're not necessary. So if I were to ask it to write a haiku about Python, it doesn't need to search the web. You can see it just writes the haiku. So this is getting into this concept of planning. The LLM has been trained to only output a function call when it's necessary, and otherwise it'll just do what you asked. This part is interesting, but in the interest of time, I'll skip it over, and you can look in the notebook. There's a couple sections that are a little bit more detailed, but we can turn our functions into these specs automatically. So we have this function search web, and we want to get it into this description for OpenAI. And the kind of brief answer is Python has a great module called inspect that actually allows us to use functions as structured data. We get parameters, we get descriptions, and so you could write a function like this, which, again, you should review in the notebook, but it would basically let us go from the function to this tool object, and that's what a lot of frameworks will do for you, so that you don't have to type out this like OpenAPI spec. So if we combine this all together, we can write a function that basically takes in our Python functions. It sends a call to the chat completions API. It gets back the tool calls. And now this is the last bit, which is a while loop. And the importance of this is that we want to keep looping while the LLM is telling us to call these tools. So imagine like a search. It might say call search, and I call it, and I give it the results, but then the LLM might predict that it doesn't have enough information, and so it might say call search again. And so this is where the while loop comes in, is you can't necessarily be sure in your overall agent system that you're done after the first time you call the tools. The point of kind of creating this agent is to give it more control over when it actually finishes the task. So we're actually going to loop until it produces text. While it's still producing tool calls, we're going to satisfy those by calling the function and giving it more results. And so then we go through the tool calls, we get the function that it's meaning to call, we load the parameters, we actually call the function, and then we append that message with the results of the function. And so this kind of puts together the tool calling things. We can see it made one call, we gave it the results, and it did that. So that's tool calling. We can now add back in the memory component that I mentioned earlier to get it kind of a full agent. So basically, we combine the tracking of the messages list with what we went over in tool calling. So now we have an agent that can call tools, and it is keeping track of the conversation history in the way that we saw in the first example. So I can say, hi, I'm interested in AI, and it doesn't call a tool, it just kind of gives me an answer. But now, when I ask it, can you find some events in Ohio I could go to, it's going to remember the first part of the conversation, and it's going to actually search specifically for AI events, and it's going to give me that by combining memory of the first message with this search tool that it has. And so it shows me some AI events in Ohio. Although you can see, even now, it's not perfect because it shows me some that were in the past. So we would probably need to iterate on this system in order to filter that out. So moving on to agent frameworks. That was a lot of code, right? Like even this function, I mean, it's not like terrible, but you wouldn't want to write this every time you write an agent. It's good for understanding what we're doing, but you don't want to write it out every time. And so luckily, there's some great Python frameworks that work on top of this basic OpenAI SDK. And so this one I'm going to show you is called CrewAI. And basically, I can set up my agent, I can give it a tool, and then I can give it a task, and I run it. And the other nice thing about the frameworks is a lot of them incorporate observability. So this has a lot better logging where I can see, okay, the agent ran, and it is using the search web tool, and it has the query, and here's the output. So some of the stuff that I was printing is now like available in a much better format if you use this framework. So that's kind of the result, and we can print it, and we can see we got the same results, and that was like that much code instead of like the whole function. Yeah, so I guess they finished up early. So sometimes you need more than one tool, and to demonstrate this, I can say who is speaking at Pyohio. And it's searching the web, but at least if it runs the way that I saw it in practice, it's not going to get all the speakers, because all it can do is look at search results, and that only gives it a preview of who's speaking. So in the end, it's very verbose. In the end, I think it's going to give us some subset. It's still going. This is the while loop part I mentioned, is like it's going to keep searching until it feels like, based on its predictions, that it has enough information. Okay. Print result. Well, that's interesting. It got exhausted. The agent got tired of searching. So what was the problem? The problem is it can only search, but it can't go to the web page. So I need to give it another tool. And I wrote this function, which can fetch a URL. And this is just a Python function using requests. And it'll get a list of all the speakers. So now my agent has two tools. It can not only search, but when it's necessary, it can get a URL. And so if I run this again, it hopefully will have a much simpler time, because now it's able to actually visit these URLs, and you can see that it's actually fetching the speaker's URL, and that's a lot easier than continually trying to search and using only the search previews. So now this is like a full list of speakers. So this is a demonstration of when like multiple tools is useful. Okay, I'm going to briefly do multi-agent. So multi-agent is useful in this case when you want to kind of do a antagonistic relationship. So let's say I wanted to do pros and cons of Python. If you've ever had an AI review your work, you know that it's not really good at taking on both sides. It's either going to be like really nice to you, or you can get it to critique you by giving it specific instructions, but like it's not really good at doing both. It kind of tends to do one or the other depending on what you tell it. And so multi-agent is a great use case for this, because now I have multiple LLMs with different instructions where I say one of you is a Python promoter, one of you is a Python critiquer, and you're also able to search the internet and find reasons to use Python and reasons to not. And then you can combine those results in the end. So we can see that we gathered some pros and some cons. So that's one example. Another good example of multi-agent is like creator and verifier, another antagonistic thing where one thing gathers and one thing checks. Okay, I'll skip over eval, but you should check out that part, and then just two final slides. The real world example is like you might have used Cursor or Windsurf, a coding agent, and the point of this talk is basically to say there's no magic inside of it. Behind that scenes is an LLM and very good design of what tools it has to use. So Cursor can call things like ls and grep and cd, and those tools are very well described, so it understands what it needs to do at different times. But in the end, those are all just functions. They're using some LLM from OpenAI, and they've really done a good job of describing the tools. So hopefully, with this talk, you can look at the code and understand how you could do that yourself. And to close with some practical tips, you really want to do a good job describing your functions, because it can only do as well as you have given the function and the parameters clear names, written a good doc string. These are things actually that we already try to do to communicate the code to humans, but it's even more necessary to do for LLMs because they have even less context maybe than your coworker. And another thing to keep in mind is that your performance will decline as you get more tools because it has more choices over what to do. Anyway, hopefully you can take this code and do something practical with it and understand AI agents. There's my social media. If you want to talk to me after, I'll be outside. Thank you all so much.